All right, so today we're in section 13.4, graphing linear equations. That's nothing new. You're going to plot points on a graph, and what does linear mean? What's it going to look like on the graph?
Straight.
A straight line. So that's nothing new. What is new is the way that we're going to do it. All right, so we just talked about the fact that setting up a table the way that we've been doing is one way to graph a linear equation. Now I'm teaching you another way, and it's actually faster. All right, so we like the faster way. It doesn't mean that tables don't have value, but there's another way that you can graph. All right, but before we do that, and this is not in your notes because I just threw it in, we need to spend some time reviewing what you learned yesterday. All right, so with proportional relationships, the most difficult part of it is understanding that X and Y now have a value, okay? So you could think of it like a scenario. Y'all know what a scenario is, right? It's like a story, okay? So I want you to just take a minute. Can everybody read that? It's a little small. Okay, I'll read it to you then. It says the number Y of objects. So while we're reading this, I want you to think in your mind, what does Y stand for and what does X stand for? So it says the number Y of objects a machine produces is proportional. All right, so there we go. I know it's proportional, so I know there's going to be a rate. What letter stands for rate? M. Very good. All right, to the time X, what? In minutes that the machine runs. So the machine produces 5 objects in 4 minutes. Letter A says to write an equation that represents the situation. So I'm going to do A down here. You can follow along with me. If you have a blank space somewhere in your notes, you can write this down, but don't feel like you have to. I just want you to pay attention and kind of just follow along with me. All right, so I always start off with Y equals MX. You say, well, how did I know to do that? Because it said that it was proportional. As soon as I know it's a proportional relationship, this is my framework. Y equals MX, where M stands for the rate. So now I have to recognize, what did Y stand for? The number of objects a machine produces. What did X stand for? Minutes, okay? So now it gives me this information at the end. I need to know, where do I plug in the 5 and where do I plug in the 4? So Y stood for objects. So does 5 stand for objects or does 4? 5. It says 5 objects. So 5 objects gets plugged in for Y. So you're going to say 5. Does everybody get to see why I plugged in 5 for Y? Equals 4 minutes. Well, I just said that X stands for minutes. Okay, so I'm going to say 4M. Remember, multiplying M and X, I can switch them around. I want to write my number first. Now, I want you to divide both sides by 4. All right, so M equals what? 5 over 4. All right, so that's my M. So Y equals 5 over 4x. We're not going to graph the equation, but we will interpret the slope. All right, so I don't know why it says to interpret the slope, because it basically already told us the slope in the scenario, but we'll talk about it anyway. All right, so if I produced, all right, so to interpret the slope, I'm basically just taking my rise value and my run value. Do you remember how we said slope is rise over run? All right, so what I'm going to do is, if 5 is my rise value, and what did Y stand for? What did Y stand for? Objects. This means 5 objects, and my run value was minutes, so I produce 5 objects in 4 minutes. That's all I do to interpret the slope. So does everybody see how I did that? Rise over run. My Y value was objects, so this means 5 objects in 4 minutes. That's how I would interpret the slope. So how many objects does the machine produce in 1 hour? So what do you think? If X stands for minutes,
60.
Yes, I must convert hours to minutes and plug in 60 for X. So Y equals 5 over 4 times 60 over 1. Could I cross reduce anything to make my life a little bit easier?
Yes.
Yeah, what could I cross reduce? 4 and the 60 to 1 and 15, I believe. So Y equals, and remember, Y stands for objects. So what I'm saying is the number of objects produced in 60 minutes, Y equals 75 objects. And you could take any value now. Now that you know the rate, you can take any value. So again, it's just practicing interpreting the slope. This is one of the most difficult concepts you'll learn all year. All right, and I say that to kind of let you off the hook. It's going to take some time for you to learn this, to truly learn it. All right? But, so that's why we do the review. So what are we doing today? All right, today we're learning a little bit more about graphing equations. So we're going to learn what's called intercepts. Well, when something intercepts something, what's actually happening? It's crossing it, right? So if I'm talking about the x-intercept, that's the point on the graph where the line passes through the x-axis. Simple enough, right? So what do you think the y-intercept is? It's the point on the y-axis where the line crosses through the y-axis. It's the value where it crosses through y. So x and y-intercept, you're going to be asked those questions. And here's our old friend again. Remember that guy? Y equals mx plus b. Highlight it, star it, slope-intercept form. But now we're taking it a step further. We've already talked about what m equals. M is my slope or my rate of change between x and y. B is my y-intercept. I want you also to write next to it, this is my starting value. So yesterday with proportional relationships, our starting value was always 0. When x is 0, so is y. The b value, if there is one there, that means it's not 0, 0. All right, maybe like we said with the fair example, maybe you have to pay $10 just to get in, and then you pay your rate after that. Does that make sense? If there's free admission, then that would be a proportional relationship where things start at 0. All right, so my y-intercept is my starting value. In example 1, all we're doing is we're learning how to identify, all right? So I'm going to teach you that there's a way that you can graph this equation with no work at all just by looking at it. You know how to graph it. You don't have to do a table, all right? But in order to be able to do that, you have to be able to write on the dot, say, this is my slope and this is my y-intercept. So again, the framework, y equals mx plus b. All right? Remind yourself, m is my slope and b is my y-intercept. So the number that's in that place in the equation, that's that value. So m equals, oh, and one more thing. It has to be in this format in order for you to say m and b. So if it's not in slope-intercept, you have to get it there. All right, we'll see that in a later example. So it is in slope-intercept. Does everybody agree? This equation is in slope-intercept. All right? So which number is in the same place as the m value? 3. You can also say it 3 over 1. Say, well, why would I want to say 3 over 1? Because with slope, when you're graphing it, you have to have a rise and you have to have a run. So anytime it's a whole number, your run is 1. Okay? So whole numbers, run is 1. That kind of rhymes. Do you like the catch? Run is 1. Okay? It's never 0. We'll talk about that in a minute. What number is in the place value of b? Negative 6. Is anybody wondering why this is negative when there's a plus in the formula? Has anybody wondered that? Okay, well, just in case you are wondering, if I did do plus a negative 6, what's plus a negative? It's just minus, okay? So even though there's a plus sign in the formula, that just means you're adding the y-intercept. Well, if you're adding a negative, that's the same thing as minusing, okay? So don't be thrown off by that if you were. All right, I want you to try the next one, m equals b equals. But before you say m equals b equals, is it ready? Is it ready to graph? Is it and by that, I mean, is it in slope intercept? Yes, it is. It has y solved for, and then your mx plus b. All right, Sebastian, what is your m value? Negative 2/3. And Julia, what's your b value? Positive 3. All right, how are we doing on finding m and finding b in the equation? You guys doing okay? All right, good. Now, I've got these equations. What do you notice that's different about these equations? What do you guys notice? Just tell me.
They're not in slope intercept.
They're not in slope intercept. They're not ready to graph. I can't say m is 3. Okay? I can't say b is 6. It might be, but I have to get it in slope intercept first. So if I need to solve for y, I know you guys love drawing the hearts. Okay? All right, but it is teaching you what I'm solving for, I save for last. How can I get the entire 3x to move to the other side? What do I need to do to cancel out 3x? Subtract it. Do you see why I'm subtracting and not dividing? So a lot of times people see 3x and they think I need to divide by 3. Well, if you do that, you're leaving the x over there. You need to move the entire term. All right? Bring your y down. And now, which term would you write next? Which term would you write next? Just tell me. Negative 3x, because remember, it's got to be in slope intercept. The x term comes first. Would it be plus 6 or minus 6? Plus 6. Now is it ready to graph? Yes. So now I can say m equals and b equals. All right, Malia, what do you think m equals? 3. Not 3, but negative 3. Or could I say negative 3 over 1? What does that remind me? That my rise is negative 3, and what's my run? 1. Okay, so we'll look at that when we start graphing them. What does b equal, Mariana? 6. All right, this next one's tough. I'm going to cut you loose for about a minute and see if you guys can get ahead of me. If you're stuck, don't feel bad. Don't get, we're still really early on in the process, but I just want to see, I want to give you guys a chance to do this one before I show you. All right, so we solve for y. What do we do first? What do we do first? Add 4x. Add 4x. 2y equals, which term do I bring down first? The 4x plus 12. All right, now what I do across the whole thing? Divide everything by 2. Now that it's in slope intercept, all right, y equals 4 over 2, 2x plus 6. What is my m? 2 and 2 over 1. And what is my b? 6. M and b. All right, great job. So now, why do I do that in the first place? On your homework last night, you had a couple of these, and what did you have to have? You had to have your table, right? And what's the set of values you would have used? Negative 1, 0, 1, plug them in, get your y. You don't have to do any of that, okay? And here's why. You can use the equation. I said that, now I want you to write the format right underneath. Y equals mx plus b. What does b stand for again? What does B stand for? Look back in your notes. B is the y-intercept. B is the y-intercept. This number on the end of the equation is the value where the line passes through the y-axis. I know for a fact, according to my equation, that the line will pass through the y-axis at a value of 3. I know that. So I can start with my y-intercept, and now, what is my slope? What is my slope? My m equals what? Negative 3 over what? Over 1. So now from that point on my y-intercept, I can rise and run. Now, if I'm rising negative 3, which way am I going? Down 3. So I'm going to count down 3 from that point. I'm going to go down 1, 2, 3, and I'm going to go over 1 and plot my point. And now I have 2 points, which is all I need to draw my line on the graph. And that's it. This is the exact same line that you would have drawn had you have done a table. Okay? But now, other than just the work that I showed you of how I got the numbers, you can just look at an equation and you can know how to graph it. Okay? All right. Next example. Okay, so now I'm going to... Oh, hold on. Got to go back. One more step. Sorry, I forgot one more thing. We have to identify the x-intercept. So we know the y-intercept from the equation. What is the x-intercept? Meaning, what value on the x-axis does the line pass through? X-intercept is 1, because that's where it crosses through the x-axis. You will find the x-intercept after you graph the line. Okay? The x-intercept just happened to be on one of the points. Most of the time it's not. All right? Okay, I'm glad I remembered that. So now let's do another one. I want you to try to put the first point on the graph. All right? Based on what we just said, where would my first point go on the graph? Just see if you can remember where it would go. All right, does anybody want to volunteer? Where does my first point go on the graph? Would it go on the y-axis or the x? On the y-axis. And the last number in the equation tells me it goes on a y value of what? Positive 1. So I go up to a 1 on the y-axis and I plot my point. Does everybody see why my point went there? Now, what is my slope? My slope is negative 1/2. Does that mean my rise is negative or my run? My rise. It's always the rise. I never go backwards. So my slope, I go down 1 over 2, and I plot my point and draw my line. Plot my point and draw my line.
Oh, I thought we put it in between the 0 and the 1 because of 1/2.
That's exactly what I did.
Did I put it in between the 0 and the 1?
Yeah, that's what I thought it was.
Oh, because it's half. But remember, it's always rise over run. So your slope is negative 1/2. This is rise over run. It's 2 separate values. Okay? All right, I'm glad you said that. So now, what is my x-intercept? What's my x-intercept? Where does the line cross the x-axis? Positive 2. X-intercept is positive 2. So don't forget to write that part. How are you guys doing?
Great.
Okay. All right. Modeling real life. So this is kind of like your Uber example that we talked about the other day. All right. Now remember, not Uber Eats. Okay. Remember what we said. There is going to be a category. Y stands for something now. I want you to read the equation and highlight or circle what Y stands for and what X stands for. That helps you understand what the equation is telling you. Okay, what does Y stand for? Dollars. What does X stand for? Miles is represented by the equation. Y equals, I want you to rewrite it. Y equals, and I want you to write 2.5 over 1. I realize it's a decimal. Okay? I realize it's a decimal, but we're still going to write it that way. X plus 2. Let's go ahead and graph the equation. Before we do the interpret, let's graph the equation, then we'll talk about what it means. Where does my first point go on my graph? Okay, positive 2. So I go up 2. And then where do I go? I go up 2.5 and over 1. Up 2.5 and then I go over 1. And I plot my point, so just do it right in the middle. And I draw my line through it. Okay, so what is the slope telling me? And what is the y-intercept telling me? Remember, the last number in the equation is my y-intercept. What did I have you write next to the B in the very first, when we were talking about the definitions? It is but it's also my starting value. My starting value. When X is 0, all right? So in order for it to be the y-intercept, in order for it to cross the y-axis, it can't go either way on X, right? The ordered pair for the y-intercept is 0, 2. Do you understand that? That means in order for it to cross the y-axis, my X value has to be 0. What did X stand for? Miles. So, how many miles did I go on the y-intercept? 0. That's why it's $2 extra. It's $2 just for them to show up at your doorstep. Your starting value before you go anywhere is $2. Okay? So your y-intercept interpretation, you can do these in any order. You can do the y-intercept first or you can do the slope first. Y-intercept, starting cost. Remember, this is starting value when you go 0 miles. Starting cost is $2. All right? Does that make sense? You've gone nowhere. Just for them to show up on your doorstep. Now your slope interpretation. What is your rate? Remember, the slope is your rate. So look here. 2.5 over 1. I want you to write it down. 2.5 over 1. This is rise over run, which means y over x. What did y stand for? What did y stand for? Dollars. What did x stand for? Miles. So this 2.5, that means dollars. So you need to put that in dollar format. This 1 stands for miles. So you're going to write that. Now, these middle steps, you're eventually just going to know. But this trains your mind to think, my top number is my rise value. What did rise stand for? In this case, it's dollars. My bottom one is my run. It stands for miles. That's X. So I'm going to say the taxi costs $2.50. Remember, the top one was dollars per how many miles? 1 mile. That's your slope interpretation. That's the rate. When we went to New Orleans, our taxi ride from the airport to the hotel was $100 for a 25-minute drive. Yes. So, yeah, I believe it. I don't know what that rate was, but it was a lot. All right. But, guys, listen. So, if you need to go 10 miles, can you use the rate to figure out how much you're going to pay? Yeah, $2.50 times 10. So, you're going to pay $25. So the rate helps you predict, well, if you only have $20 in your pocket, you ain't going 10 miles, right? Okay, so that's how it's going to help you. It's going to take some practice. Do you feel like you're better today at it than you were yesterday? All you need to do is get better, all right? We're not ready to take a test, but we're getting better and improving. Yeah, that was the last example anyway. All right, so that's it for today.